Assalamualaikum warahmatullahi wabarakatuh. My name is Yonathan Iwangsa Sima. I'm from Marine Engineering Department, and my last number of my NRP is 168. And now I will try to solve the problem of simple harmonic motion, and I'm sorry if there is a disturbing sound because my neighbor have an appetite. The first question is, you are sitting on a surfboard that is riding up and down on some swells. The board's vertical displacement is given by y equal with 1.2 meters cos time half second plus p divided by 6. And the first question is, find the amplitude, angular frequency, phase constant, frequency, and period of the motion. And as we know that we have this equation and we comparing with this one, y equal with amplitude cos angular time plus this one, and we know that the amplitude is 1.2 from here. This one is same, and then the angular frequency, this one, this angular frequency same with it, and this one is half radian divided by second, and the phase is this one. The phase is this one, and we already get this one, and the time period is 2p divided by angular frequency, and we got this one, and the result is 4p second, and the frequency is 1 divided by period, and we already have the period, so we have this one, and the frequency is 0.8 hertz. For the second question, where is the surfboard at time is 1 second, and we can put the time to the question in here because the equation is 1.2 cos half time plus p divided by 6. So we got the position at the time 1 is 0.62 meter. And the third question is, find the velocity and acceleration as a function of time. The velocity is derivative from the position, so we have this one, and the acceleration is the derivative from the velocity, so we get this one. And the fourth question, the initial velocity and acceleration, so the time is 0. We can put the time to this equation, so we have the velocity is negative 0.3 meter. No, this one is 1. Yes, and the acceleration is negative 0.25 meter per second square. Number 2, the angular velocity is 8 radian per second, and when the time is 0, the position is 4, and the velocity is minus 25 centimeter per second. And the question is amplitude and the phase. For the second question, x function of the time. So this one is general equation, x equal with a sines omega t plus phase, and at the time is 0, we have x equal with 4, and we put this one, and we got the first equation, sinus equal with x0 divided by a, and the velocity is derivative from the position, and we have this for the equation of the velocity. And at the time is 0, the velocity is minus 25 centimeter per second, and we continue to put this one, and we got the second equation. Second equation is cos this one equal with velocity 0 divided by a omega, and on squaring equation 1 and equation 2 and adding them together, we have, so we squaring equation 1 and equation 2, equation 1 and equation 2, we can squaring them, and we got the amplitude is 5 centimeters. We can continue to find the value of the phase. The value of the phase can how by obtained by dividing equation 1 and equation 2. This one dividing by this one. So we got the phase is 2.23 radian, and the equation of the position of the function of the time is x equal 5 times 80 radian per second plus 2.23 radian from the general equation. General equation is this one. Third exercise, given data K is 196 Newton per meter and mass is 2 kg and X is 0.05 meter. The question is angular frequency and period, and B is X function of the time. The answer of A is angular frequency is root of K per meter. So we get this one, 9.9 radian per second, and the frequency is the angular frequency per 2p, and we got this one. So the frequency is 1.58 hertz and the period is 1 point frequency. So this one, and the period is 0.6343 second, and the equation is the X function of the time. So this one is the general equation. So we already got the another data, so we just put here, and we got this one. The X equal with 0.05 meter cos 9.90 plus phase. And the fourth exercise, we got this one equation. So the question is maximum speed of our Vmax and then Tmax and Amax, and when does the maximum of the magnitude of the acceleration first occur after t equal with 0. The answer of the A is Vmax. Vmax is 2p amplitude per t. So we can this one, and Vmax is 9.9 multiplied by 0.05, so Vmax is 0.495 meter per second square. And the second question is Tmax. From the equation of the phi, this one is derivative from the x, this one is derivative, and Vmax is negative a angular frequency since 9.9 Tmax, and this one we can just put the another data that we got before, and we got this Tmax is 9.0909 second, and C is the derivative, the A is the derivative of the velocity of the or the speed, and this one we get this one. So the angular is this one, and Amax happen when the first occur. Amax happen when the t is 10p divided by 9.9, because 9.9 is this one negative 2. And the fifth exercise, identify mass is 3 and amplitude is 0.054 meter, and this one is the period is 2 seconds, and question is what total energy and Vmax and x1 is half max value of the V. And this one is the total energy is same with mechanical energy and potential energy plus kinetic energy. It total energy is half k x squared plus 0, because this one is 0, and half kx is the total energy, and we can put this one. The k is the equation of the k is m multiplied by angular frequency square. We can put it here, and x is a cos angular frequency plus phase, and we can put here too, and the total energy is half mass angular frequency square and amplitude square multiplied by cos omega t plus phase, and then the angular frequency is like this, 2p divided by t, and we got this one, 3.14 radian per second is the angular frequency or angular speed. And then this one, total energy is, we just put here another data that we get before, and we get the total energy is 0.0234 joule. Next question is Vmax. Vmax is amplitude multiplied by omega, and then 0.04 multiplied by 3.14, and Vmax is 0.1256 meter per second. 6 exercise. You claim that the phase of the comfortable wall can be predicted if we model each leg as a physical pendulum. Your teacher is skeptical about this claim and asks you to back it up. Is your claim correct? And the answer is the simple pendulum model predict energy expenditure for the transition between steps. This transition explains why medical energy must be dissipated in the periodic motion of the limbs and requires a positive work. This offers quantitative prediction, and this measurement associates with step-to-step transition as a major consequence of walking like an inverted pendulum. 7 exercise. A uniform rod of mass m and length L is free to swing about a horizontal perpendicular to the rod and a distance x from the rod center. Find the period of oscillation for small angular displacement of the rod. And we know that the m is m, l, 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 x is x, and e is ml squared divided by 12, and period is 2p root 1 divided by mgd, and we can accumulate that, and t is 2p 1 divided by 12gx. Exercise 8. A block with mass m attached to a horizontal spring with force constant k is moving with simple harmonic motion having amplitude a1. At the instant when the block passes through its equilibrium position, a lump of putty with mass m is dropped vertically on the block from a very small edge and stick to it. And the first question is find the new amplitude and period, and B is repeat part A if the putty is dropped onto the block when it is at one end of its part. First case is before the lump of putty is dropped, the total mechanical energy of the block and spring is E1 equal half k A1 square. And then since the block is at the equilibrium position, U is 0 and the energy is purely kinetic. Let V1 be the speed of the block at the equilibrium position when half the E1 is half m V2 square equal with a half k A1 square, and we got the V1 is root of k divided by m and multiplied by A1. And then during the process, momentum of the system in horizontal direction is conserved. Let V2 be the speed of the combined mass. Then the m1 plus m and m plus m multiplied by V2 equal with m V1, and we got the V2 equal with m divided by m plus m V. And then this one is V1, yes. And now let A2 be the amplitude of the of Now let A2 be the amplitude afterward, then the A2 equal with this one, and substituting the proper values, and we have amplitude 2 is A1 divided by root of M divided by M plus M, and further this one is the period 2. And then when the putty drops on the block is instantaneously at rest. All the mechanical energy is stored in the spring as potential energy. Again, the momentum in horizontal direction is conserved during the process, but now it is zero just before and after putty is dropped. So in this case, adding the extra mass of putty has no effect on the mechanical energy. And this one is the equation, and the amplitude is still A1. This A2, this one, A2 is this one, the same. Then exercise, we know that this one is the spring and have the force 1 and force 2 up and weight is down, and we know that this one sigma Fy equal with F1 plus F2 minus weight because different direction, and we know this one is the first equation, and sigma Fy is F1 plus sigma F plus F2 plus sigma F equal with mg, and we know that the sigma F is the minus kx, and we can operate this, and we got this one, the second equation. Based on the Hooke law, this one is root of k divided by m, one is root of 2k per m, and we know that the frequency is the 1 divided by 2p omega equal with 1 divided by 2p multiplied by root of 2k divided by m. That's all, thank you, and I'm sorry for the next number I cannot show to you because the file is too big, I cannot render it, but I'll show you in my paper assignment. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.